right, today we're going to take a look at section 9.3. We're going to talk about another couple of applications in probability. I think we're going to do one of them today and we'll do the other one on Friday is how it'll divvy up. The first application in probability that we're going to talk about is the application of odds. So I know even in you guys' group work, maybe at the last class one on 9.2 or maybe on 9.1, somebody said the word odds. And I was like, wait a minute, does it say odds? And they went back and they're like, oh no, it says probability. And I said, because we're going to talk about odds. So odds are a little different than probability. So if P of A is the probability of an event, and P of A complement is that the probability of the event does not occur, then you have two types of odds. One are odds. Sometimes they just say odds. Or they might actually say odds in favor of. The odds or the odds in favor of the event are the probability of A divided by the probability of A complement. And if you take a look, be real careful, it's kind of tiny, but there's a bar on top of this, right? So that's the A complement part. And we had an equation that talked about what the probability of A complement was. It's 1 minus the probability of A. It means the A doesn't occur. So it's 1 minus the probability of A for the probability. That's the odds in favor, or the odds of an event occurring. The odds against the event occurring is simply the flip of the fraction. So you see the probability of A over A complement flips upside down, and now we have the probability of A complement over the probability of A, or we have the flip of the equivalent fraction after that. Okay? Do you remember when we talked about the ratios? It happened on your first exam, I think, where you had to decide that if things were a part-to-part ratio or a part-to-whole ratio. Remember that? Okay, odds is the same kind of thing. What probability does is it's a part-to-whole ratio. What's the probability the event will occur? How many ways can the event occur compared to how many ways can anything occur? Right? We're comparing it to the whole. What odds do is they compare your likelihood of something to happen compared to the likelihood that it will not happen. So you're comparing part to part instead. So this is a really good example that talks about it from that perspective especially. You've got a set of 8 marbles, 5 are red and 3 are white. You want to choose one at random. Okay, so what we've done before is the first part, part A, probability. So the probability that we will choose a red is we take the number of red marbles, which is how many? 5, and we divide by the total number of marbles, which is 8. This is a part to whole ratio, and it's the equivalent probability of drawing a red. Odds, which is part B, that I will draw a red, takes my 5 red, and it compares it to the not red, whatever is left. And how many are not red? There are 3 not red. This is a part-to-part comparison. So this is the red compared to all, and this is the red compared to not red. So you'll remember we talked about probabilities. Probabilities are always numbers between 0 and 1. That's 5/8. Odds doesn't have that. 5 to 3 here, that's actually, if I divided it out, that's actually a number bigger than 1. So you can have an odds that's better than a 1 odds, right? A 1-to-1 odds. But you can't do a probability like that. It doesn't work that way because of the way the comparisons are being made. You can write this way. You can also write it like we did before, like this, right? 5 to 8 and 5 to 3. No matter how you choose to write it, you do need to make sure it's reduced form, just like when we did ratios back in chapter 6. So if this, instead of saying 5 to 3, had said 9 to 3, we'd have to reduce it to 3 to 1. Okay, we never reduce it so that it doesn't have a denominator, but we would reduce the fractions values when we can divide them both equally. Numerator and denominator. So we can look at it when we have this sort of an idea of choosing objects from a number of objects, but we can actually look at it from a probability perspective too. So if the probability of rain for the day is 60%, 60% is equivalent to the decimal point 6. So you can either use it from a percent perspective or from a decimal perspective. It actually won't matter. It wants to know what are the odds against it raining. So when we're talking about odds against, what that means is we want the probability that it won't happen. So we want the probability that it won't rain compared to the probability that it rains. So the probability that it rains, it says, is 0.6. So that's actually my denominator here. Or if you prefer, you can write it as 60%. Doesn't make any difference. What is the probability then that it won't rain? 40%. So you can either write it as the decimal point 4 or as 40%. Now in either case, we're not going to leave it like what we've written it on there. It's not going to stay 40 over 60. It's not going to stay 0.4 over 0.6. So let me actually do the reducing for the 0.4 over 0.6 first. Because these are both in decimal value, we can multiply by 10 on top and bottom to turn them into whole numbers, 4 over 6. And then what can we do? Yep. So we can divide top and bottom by 2, which will simplify it to 2 to 3. Okay, so if we're thinking about it from a decimal perspective, that's how that work would look. If you're doing it right here, the 40% and the 60%, in a very real way, the percents cancel. And 40% and 60%, if I divide them both by 10, I know we don't always write it that way, but that's really what we're doing, is we're dividing both by 10. We would get 4 over 6, and then we would divide by 2 again to get the 2 to 3. Does that make sense? Okay, so you can start with decimals, or you can actually start with values where you're choosing things, and it works the same way. There is a relationship, obviously, between probability for and probability against something. I didn't say it right. Odds for and odds against something happening. So if you have the odds in favor of an event, and they are m to n, right? So this part is actually what we're using, m to n. Then the probability of the event happening is the number of ways that it happens, m, divided by the total number of things that are happening, m plus n. And then if the odds against the event m are m to n, then odds against means the n is the ways that it won't happen, right? The n is the ways that it will. And if you want the probability of the event E, then you want the will part, which is why the n gets put on the numerator. And again, the total number of possibilities is the m plus n. So I want to flip back real quick to that marbles example because it's a really good example of this particular argument. So if we have the probability and the events over here, you can see the 5 on top here for the 5 compared to the 8. What it really is it's 5 compared to 5 plus 3, right? 5 ways that I choose a red compared to the 5 plus 3 ways of doing anything. If you think about my odds here, if my odds are 5 to 3, then I have 5 compared to the 5 plus 3 that could turn them back into a probability, right? There's this interchangeable relationship going on. All right, so we're going to look at a 3-child family. Done a lot of tree diagrams, so you could be really good at them by now, right? At least if you did your homework. Looking at y'all. Okay, it's okay. We will forgive you. All right, boys and girls. Okay, so we have the first child born is a boy or girl. The second child born, so it would be a branch off of each of the boy-girl branches, would be another boy-girl. And then we have child number 3, so it's a third set of branches off of each of those at the end. And they all say boy, girl. If you want to be really precise, obviously we could put the 1/2 along every branch. But we also talked about last time that when we're working with things that are equally likely, we can also count the outcomes at the end to do our probabilities. So that's actually how we're going to think about this particular one, just because they are equally likely. Everything has 1/2 everywhere on this particular one. So there's several questions that I'm asked. Oops, sorry. 2 questions. The first one wants to know the odds of having all the same gender of children. So what does that mean to have all the same gender of children? What is that description saying? Right, all boys, which is my top branch, or all girls, which is my bottom branch. So the odds of that happening is that there's 2 ways it can happen, right? I want to compare that to the ways that that does not happen. So how many ways does it not happen? Somebody say it. 6. There are 6 branches that are not highlighted right now. There's 8 branches total. Highlighted 2, so I didn't highlight 6. So the odds of having all the same gender of children is actually a 1 to 3 odds. Okay, it's not probability. The probability is something different, but it's odds, 1 to 3. You like this one?
I like this one better.
Okay.
Probability.
How about the odds that having all the same, it says odds against. So this one said odds. This one says odds against. So odds against having all the same gender of children. If I've already found the odds in favor, which I have on part A, what do I have to do for the odds against? I just need to flip it, right? I need to take my 6 over my 2, or you could even take the reduced fraction if you wish, and so you don't have to reduce it again, 3 over 1. The odds against it happening is 3 to 1. Where do you hear odds in real life? There's lots of places. What kinds of things? Where in your life have you ever heard the word odds used? Casey?
Like sports, like what are the odds this team's going to lose to this team?
Yeah, they do it a lot with sports. So lots of sports. Football games is one of them.
That's not.
I hear odds, with football games, yeah. Any other sports that you can think of besides football games? They'll do like basketball and stuff too. There's another type of sporting event that uses them, and they use them exclusively. Horse racing, somebody said it. Horse racing uses odds exclusively, yeah. So we see them used a lot in gaming situations, and we're going to see a lot of other gaming situation things happen in this section, in the other part we're going to do. But gaming, usually somebody tells me Hunger Games. Nobody wanted to say Hunger Games this time? Yeah, it's the same idea that they're using. They're using the word in the same way there. So they talk about odds in that kind of situation. But there's other situations where we really stick with probabilities, right? Like, if you want to know the chance that it's going to rain today, nobody's telling you the odds. People don't talk like that, right? The weather people don't do that. You probably confused them if you used those words, to be honest, because they don't think of it that way, right? It's always thought of in terms of probability. So there's definitely some scenarios where we sort of gravitate towards one way of expressing, the likelihood compared to the other ways of expressing the likelihood. Okay, so that's where we're going to stop today. Expected value is the other half of this assignment. We're just done a little bit early, and you guys get a little bit of a break. All right?